All right, so we're going to move on to talk about the graphs of other trig functions besides sine and cosine. So more specifically, tangent, cotangent, secant, cosecant. All right, so first off, let's look at a little bit on the unit circle about tangent. So remember, tangent is the y coordinates over the x coordinates. So if we look, let's start with up here at pi over 2 and look at negative pi over 2. So if we found the tangent right here, we would do 1, because it's y over x, tangent is y over x, 1 over 0, and down here negative 1 over 0. Both of those would be undefined, right? So on the graph, all right, the tangent of pi over 2, and of course, if we went negative down here, this would be negative pi over 2, or positive 3 pi over 2 if you went the positive way. So if we go down this way, negative pi over 2 and positive pi over 2, the tangent of those is going to be undefined. All right, so because 1 divided by 0 and negative 1 divided by 0 gives us undefined. So at those two values on the graph, we're going to have asymptotes. All right, so we're going to have vertical asymptotes right there at those values. Now let's look what happens in between those. So if we go down negative pi over 2, and then we look over here to this next one, which would be really be negative 2 pi over 3, all right, then we get these values right here, negative square root of 3 over 2 over negative 1/2. Well, of course, that's going to divide and give us positive. Now, if we go to the positive side right here, notice that it's the same values, right? But we got a positive and a negative. So that's going to make the same value as this one, only it's going to be negative for tangent, right? If we go this way, then we're going to use the same values, but it's going to be positive. So going in this direction, if we go from from positive pi over 2, and we decrease to 0, all right, then we're going to get the same values over here that we get over here, and vice versa. So as we go around the circle this way, the values are going to be the same. So you got square root of 3 over 2 over 1/2, negative square root of 3 over 2 over negative 1/2 will be the same thing, and then square root of 2 over 2 and square root of 2 over 2, and the same thing right here, only they're negatives, so the negatives are going to cancel and be positive. Same thing right here, and then right here you get 0 over 1 and 0 over negative 1. Both of them give you 0, and then the same is going to happen as you go around. So my whole point right here is to show you that for tangent, the period, the amount that it goes before it repeats is not 2 pi like it was for sine and cosine. For sine and cosine, we went around a full circle before we started to repeat ourselves again, right? Because sine and cosine were just these individual numbers, and those individual numbers for the y-axis, or the y value or the x value, they never repeated themselves until we got all the way around a full circle. That's when they started repeating the same pattern again. But for tangent, it's going to repeat a pattern for just going 1 pi. Once you go half of a circle, it repeats the pattern over again. So if you start here and go this way, and then once you get to here, you get another vertical asymptote, and then it starts repeating the same point that you had up here, and here and here and here and here, and so on and so on. And then once you get here, now it starts repeating itself again. So my whole point is that tangent has a period of pi instead of a period of 2 pi. All right, so a lot of explanation just to get to that. So now let's actually look at graphing a tangent function. All right, so the first thing you want to do is determine what your period is. So the period is now, instead of doing 2 pi divided by b, we're just going to do pi divided by b. All right, so the period is going to be pi divided by b. And again, in this situation, you can tell b is 1/2 because it's 1/2 times x. B is whatever is multiplied by x still. Pi divided by 1/2 is the same as pi times 2 over 1, so 2 pi. So normally our tangent period is pi, but because we have a b of 1/2, it changes it to 2 pi, which is what we normally would have for sine and cosine. All right, so second part. So remember how for sine and cosine, we take the bx minus c and set it equal to 0 and 2 pi to find our first and last key points? Well, we're going to do the same thing here, but because tangent doesn't have a period from 0 to 2 pi, its period goes from negative pi over 2 to positive pi over 2. That's what we're going to use. So we're going to say x over 2 equals negative pi over 2, and x over 2 equals positive pi over 2. Those are going to be the values we use to find our first and last key points, not 0 and 2 pi, because the period for tangent is different. All right, so we times by 2 on both sides, that gives us x equals negative pi. Same thing on this one, and that gives us x equals positive pi. So our first and last key points here are going to be negative pi and positive pi. All right, then the third step is to do what we normally do. We take the period, right, which is 2 pi, and divide it by 4 to figure out the distance in our between our 5 key points. So that gives us pi over 2. All right, so the distance from our first key point to our second one is pi over 2. So now the fourth step is to write your key points. All right, so your first key point starts at negative pi. The second one, we're going to add half a pi, so that gives us negative half, because we got negative 1 plus a half is negative half. All right, and then this the third one, we're going to add another half, that's 0, and add another pi over 2. And then our last key point is going to be another pi over 2, which gives us pi. All right, so now we've got the x coordinates. The way the y coordinates work for a tangent function is your first and last key points, the y value is always infinity. Okay, now you're like, well, what does that mean? All that means is that that's where we have an asymptote. Okay, so we have an asymptote at that value. The y value is infinity, the y point goes up forever and ever and ever to the asymptote, right? So at those, we're just going to have asymptotes. So I'll put a little note right there next to those. Those first and last ones are always your asymptotes. All right, now in the middle, the very middle point, that's your intercept. All right, so that one's going to be our intercept. Then the other points, okay, you're going to look at, you know how we normally have an amplitude with sine and cosine? Well, we don't have an amplitude for tangent, but that number in front is still important. Whatever that number that's in front is the number that we're going to use for these, just like we would normally do for sine and cosine. All right, so the first one that you had, that second key point, that's going to be the negative of that number that's multiplying by tangent. And then the last one's going to be positive. Okay, of course, if that was a negative tangent, then they would swap, just like the maximums and minimums swap for sine and cosine. The first one will be positive 1, and the second one will be negative 1. So you got to pay attention still if the sign's positive or negative. All right, so let's graph these. So at negative pi, we're going to have an asymptote. And then at positive pi, we're going to have an asymptote. All right, then at negative pi over 2, we're going to have a value down at negative 1. At 0, we've got a point at 0. And then at pi over 2, we've got a point up at 1. All right, so this is going to kind of curve. It's going to approach the asymptote, and it's going to curve in, and curve up, and approach the asymptote again. All right, so that's essentially what the tangent function is going to look like. Now that's going to repeat itself every 2 pi, right? The period right here that we had was 2 pi. So every 2 pi, that's going to repeat. So over at 3 pi, you'd have another vertical asymptote. Right? And then in the middle, you've got that point. Down here, you've got this one. Up here, you got this one. And it's going to repeat that same thing right there. And of course, the same thing over at negative 3 pi. Okay, and it just depends. You say, well, how do I know how many of them I have to graph? It just depends on what they tell you. If they say graph from negative 3 pi to positive 3 pi, then you need to put all 3 of them. If they just say graph one period of the function, then you just need to graph one of them. All right, so it just depends on what they say. So that's kind of what your tangent function is going to look like for this function tangent of x over 2. All right, so just follow those same steps right here. You try this one. Notice that the number in front is negative. So remember, that's going to change your points from being the first one being negative and the second being positive to the first one being positive and the second one being negative. All right, so instead of it being like on this one, instead of just using negative 1 on the second key point and positive 1 on the fourth one, they're going to swap. All right. All right, so give that one a try, and I'll go over it. So your period right here is pi over 2, because you've got 2 times x, so you've got to take pi and divide by 2, right? We don't use 2 pi for tangent, we just use pi. So pi divided by 2 is your period. Then you set 2x equal to negative pi over 2 and positive pi over 2, right? That's always the things we use for tangent. Divide by 2 on both sides, so you get x is negative pi over 4 and x is positive pi over 4. So those are your first and last key points. Now we take the period for the third step, which is pi over 2, and we divide that by 4 in order to figure out the distance between each key point. Whenever you do that, you get pi over 8. So now we can write our key points. The first one is going to be negative pi over 4, infinity. The second one, we're going to add pi over 8 to negative pi over 4, and that's going to give us negative pi over 8. And then the next one, we're going to add another pi over 8, we get 0. And another pi over 8, we get pi over 8. And then the last one, we have pi over 8, and we get pi over 4, which we expect to be our last key point. Okay, so now to figure out the y values, of course the last one's infinity because it's the last key point's the asymptote. Now, in the middle, the number in front was 3, right? But it was negative, so that means this first one's going to be negative 3, or sorry, positive 3, because the negative switches it. And then middle 0, and then this one's negative 3. So we can graph those. Negative pi over 4 and infinity is going to have, so that's going to be an asymptote right there. Positive pi over 4 is going to be an asymptote. And then we've got negative pi over 8, 3. It's up here, 0, 0. And then negative 3 at positive pi over 8. So now your curve is just going to kind of be switched around. All right. So there is one period. And of course, you could repeat that out another period. So you come over 1, 2, 3, 4. You could do it out to 3 pi over 4 and put the same points, right? And do as many periods of it as you need to get whatever they're asking for. All right, so let's move on now. That's the tangent function. And what's cool about cotangent is it's essentially the exact same thing, only the flip of it, right? The inverse of it. So all you got to do for cotangent is do the exact same thing. The period is still the same. Everything's still the same, except with cotangent, the first point is in general is the negative one, or sorry, is the positive one, and the second point that you're going to graph is the negative one. So instead of the basic tangent went like this, and when we made the number in front of negative, it switched it. Well, cotangent is just this one right here to start. And if you put the negative, now it makes it do this. But everything else is exactly the same as tangent. So let's do a cotangent one real quick. First of all, the period is going to be pi divided by 1/3, which is pi times 3 over 1. So your period is 3 pi. And the second step is to take x over 3 and equal it to negative pi over 2 and equal to positive pi over 2. So times 3 on both sides, times 3 on both sides, so x is going to equal negative 3 pi over 2 and positive 3 pi over 2. Third step, take your period, which was 3 pi, and divide it by 4. So that's going to be how much we have to add on to go from one key point to the next. And sometimes when these get a little tough with the fractions, you can just use a calculator. The first key point is negative 3 pi over 2. Second one, we're going to add 3/4 on to 3/2. That's going to give us negative 3 pi over 4. Then we add on another 3 pi over 4, that gives us 0. Add on another one, that gives us 3 pi over 4. And then we add on another one, and that gives us 3 pi over 2. Okay, so I'm still going to have infinity and infinity on the last and first key points. This middle one's still going to be 0. But now, it's cotangent, right? That number that's in front is what we're going to use for our second and fourth points. But for cotangent, the first one is positive, and the second one is negative. All right? Of course, if that was negative 2, then they would swap. The second one will be positive 2, first one will be negative 2. So now we can graph those, negative 3 pi over 2. So negative 3/2 will be right here. And then positive 3/2 will be right here. So there's our asymptotes, and then negative 3/4. So 3/4 is, this is about half pi right here. So we got to go over halfway from there to pi. So about right here is going to be our point 2. And then 0, 0. And then about halfway between there and down to negative 2. So we can see how this is going to kind of work now. All right, and that gives you a general idea of what that cotangent function should look like. So, yeah, these are really simple. If you know one, it's really easy to do the other one because cotangent is basically the same as tangent, only the second and fourth points, swap places. Instead of being positive and negative, or instead of being negative and positive, they're typically positive and negative. All right, so go ahead and pause the video, just see if you can do the next one by yourself, and I'll go over it. Okay, so first up, your period is going to give you 2 pi. Now we're going to take the x over 2 and set it equal to negative pi over 2 and set it equal to positive pi over 2. Of course, we multiply both sides by 2 and we get negative pi and positive pi. So those are our first and second key points. Now take your period, which is 2 pi, and divide it by 4. So each of our key points is going to have pi over 2 in between it. First one is going to be at negative pi, then add a half, so that's going to be negative a half, so negative pi over 2. Add another half, that gets you to 0. Add another half, that's positive pi over 2. And add another half, and that gets you to pi, which is our last key point. Of course, the first and last key points are going to have asymptotes. The middle one is at 0. And then the first one, since we're talking about cotangent, all right, we're going to look at this number right here. And since it's cotangent, that's going to be positive on the second key point and negative on the fourth key point. If it was tangent, then they would switch. Or if it was negative 1/2 times cotangent, they would switch. So let's graph negative pi, an asymptote, and positive pi has an asymptote. 0, 0. And then negative pi over 2 has a point up at a half, and positive pi over 2 has one down at negative a half. So this is going to mean our asymptote, our line's going to hold the asymptote for a while before it comes across into the points. And of course, you could make another period to the right, to the left of those asymptotes if you wanted to, or if you needed to. So let's go on and look at secant and cosecant. So the cool thing about secant and cosecant is they're very easy as long as you can graph sine and cosine. So we'll get more practice here doing sine and cosine. So first what we're going to do when we see cosecant, cosecant's the flip of sine, so we're going to treat this for a second like it's sine. All right, follow up, and so we've got to remember all our steps for sine and cosine. First step is what's your amplitude. Identify that, it's 2. Second step is find your period. And for sine and cosine, we do 2 pi divided by b. Remember, tangent's pi divided by b. Right here, b is just 1, right? So we're going to divide 2 pi by 1. Our period is still 2 pi. And in 3, we're going to take bx minus c, which is just x plus pi over 4, equal to 0, and equal it to 2 pi, right? So it's different for tangent. Remember, for tangent, it was negative pi over 2 and positive pi over 2, but for sine and cosine, it's 0 and 2 pi. All right, so we're going to subtract pi over 4, so we get negative pi over 4 is our first key point, and then subtract pi over 4 from 2 pi, and you get 7 pi over 4. So now let's write our key points. The distance between them, remember we take the period and divide it by 4. That's still the same. That's the same for tangent, sine, and cosine. All right, so we know our first key point is going to be at negative pi over 4. Then we add a half to that. That gets us to positive pi over 4. We add a half to that. That gives us 3 pi over 4. Add a half to that. That's 5 pi over 4. Because remember, we add a half, that's really adding 2/4, right? So we're just adding 2/4 each time. So we go from 1 pi over 4 to 3 pi over 4 to 5 pi over 4 to 7 pi over 4. All right, so now for sine, we got to remember how to do key points for sine. Sine always starts off as an intercept, right? 0. The middle point is an intercept, and the last point is an intercept. And then the amplitude, the second key point, remember it goes up, right? Sine always starts at goes up, down, and back up. So that second key point is the positive value, and then the fourth one is the negative value. Of course, if that one's -2, then they would swap, but this one's positive. All right, so let's graph those points now. Negative pi over 4. So negative pi over 4 puts me at right about here, so that's 0. Pi over 4 puts me right here, and that's up at 2. And then 3 pi over 4 is right here at 0. 5 pi over 4 would be down here at -2. Right, and then 7 pi over 4 would be out here somewhere. We'll kind of give a rough guess. Looks like the graph wasn't big enough on this one to put it. So that's what you want to do first, to figure out what would the sign of the graph look like. Okay. Now, the last thing all you got to do for to make it, change it from sine into cosecant, right? Because we want to do cosecant, is everywhere there's an intercept, turn that into an asymptote. So we're going to put an asymptote right here. We're going to put an asymptote right here. And then right over here, we would put an asymptote also. All right, so your intercepts become asymptotes. And then what you do is your maximum, that point is still going to be a point on your graph. All right, and your minimum is still going to be a point. So let's remember where those were. I'm going to put those in the same place they were at before. So it was at pi over 4 and 2. Right, so right in here. And then 5 pi over 4, -2, right there. All right, so those are still going to be there. But now instead of having a wave in between them, you're going to have a U shape, almost like a parabola that goes up to the asymptotes. And same thing down here, only this one's going to go down. Okay? So they go away from where the sine curve was at. All right, and that's all you have to do for secant and cosecant, is graph your sine and cosine function just like you normally would. Then once you have it graphed, turn the intercepts into asymptotes, and from your maximum to the minimums, just do the U shapes approaching the asymptotes, okay, on both sides. That's it. All right, so see if you can do the last one, and I'll go over it. Okay, so first off, amplitude right here, real easy, is 1 period 2 pi divided by 2 is pi. And then set 2x equal to 0 and 2 pi to get your first and last key points. So we get first key point 0, second or last key point's pi. And then take your period, pi divided by 4. So pi over 4 is the distance between each key point. So the first is at 0, second one's at pi over 4, the next one will be at 2 pi over 4, which is pi over half, then 3 pi over 4, and then 4 pi over 4, which is just pi. So those are our x-coordinates of our key points. Now secant, right, that is the reciprocal of cosine. So we've got to remember with cosine, we don't start with an intercept, we start with a maximum, right? The cosine key points are maximum, then an intercept, then a minimum, then an intercept, and then a maximum again, right? Of course, same thing applies if it's negative cosine, then those all switch, right? The maximums become minimums, minimums become maximums if it was a negative cosine. So since it starts with a maximum, our maximum comes from our amplitude, right? So this maximum point is going to be 1. Then the intercept, of course, will be 0. Then your minimum is going to be -1. Then 0 for an intercept, and then 1 again for the maximum. So let's graph those. 0, 1 puts a point there. Pi over 4 and 0 puts a point there. Pi over 2, -1 puts a point here. And then 3 pi over 4. And then finally pi. All right, so this is what our graph would look like for the cosine. Right there. And now to change it to be secant, right? All we got to do is turn the intercepts into asymptotes. So we're going to have an asymptote right here. I'm going to have one right here. And then, of course, we would have another one right here. So we can kind of get an idea of where the next asymptote is going to be just by how far apart they are. All right, so then what we're going to do is at the maximums and minimums, we're going to do U shapes right there, approaching the asymptotes. This one's going to go down, and this right here is going to go up. And you can do that as many periods as is necessary. And of course, you need to make sure you erase the points in between there for your cosine, right? We don't want to leave the cosine function on there. So there would be our best drawing, best sketch right there of secant of 2x. All right, so let me know if you guys have any questions on this. Hopefully it helps review cosine and sine a little bit, and isn't that much different to where it's a whole lot of new stuff Tangent's a little bit different, a couple little differences, but it's really similar to doing sine and cosine. All right, appreciate your time, and let's get to practice.